In this lesson, we'll be covering common errors and misconceptions when it comes to identity. We'll be going through 4 examples that really cover one of the most important areas that learners struggle. With identities, you'll be given the left-hand side and the right-hand side. Usually we take the side that's a bit complicated. So we want to take the left-hand side. Try to prove that the left-hand side is equal to the right-hand side. But the first area of concern when you're given cos 19 degrees minus x. That's a co-ratio. What we need to know, remember, that sine 19 alpha, for example, this gives us 90 minus the first quadrant, and we know that sine is positive, so we can just say positive. So instead of writing sine as an answer, we will write what? Cos alpha. That's really an easy system, making sure that you don't get these confused. Sine 90 plus, the second quadrant is sine positive or negative. 90 plus is positive. Cos instead of sine. Then cos 90 minus alpha. 90 minus the first quadrant is cos positive in the first quadrant, yes. Then you write, instead of cos, write sine angle, and then cos, and this is the important one, or the one that confuses a lot of learners, is cos 90 plus. 90 plus the second quadrant, and cos is negative in the quadrant, and then instead of cos, we will write sine, the reference angle. So that's what you need to know when you're dealing with the co-ratios. In this instance, we have cos 90 minus. 90 minus is the first quadrant. Cos in the first quadrant is positive. So instead of writing cos, since the co-ratio is on the right, sine 2x. And times, we come to tan on 80 plus x. So at the back of your mind, you need to be visualizing the cos diagram. The cos diagram needs to be second nature by now. You need to memorize it. I'll just write a summarized version of it. Cos or sine tan. So 90 plus, second quadrant. And we can see that it's the quadrant of t where tan is positive. So tan 180 plus, we know that tan will be positive, so we just simply write x. You may also write a positive sign there, but it doesn't matter much. I'm just leaving it out so that it doesn't seem cumbersome. And also, even positive, I was writing it so as you see the method, so you can leave it out if you wish. Plus, this is another critical area. Learners make a lot of mistakes here. Easiest way to avoid this is whenever you see sine squared, cos squared, or tan squared, put solid brackets and put the squared on the outside, and then you will write what you need to reduce inside x. That way it will simplify things, and I'll show you why this is important. So we have a double angle of sine. Reminder, the double angle of sine is equal to 2 sine of x cos of x. So simply place the 2 sine 2x by 2 sine x cos x. We know that tan is nothing more than sine cos x plus what we have here becomes very interesting, because sine 360 minus is the fourth quadrant, and sine is negative this quadrant, so it will be negative sine angle squared. Then watch what happens closely. Move on. We have cos and cos will cancel, goes all of these under 1, and all the numerator is multiplied. We're left with 2 sine times sine is sine squared x plus everything all squared will give you positive. sine squared. If you wish, you can just simply say negative sine x times negative x, which will be negative and negative multiplied will be positive, sine and sine multiplied squared x. So the point I was drawing to where this could easily go south is that you forget to put your solid brackets, as we did here. Many learners would simply see this and say sine squared 260 minus x and simply say minus sine squared, which is incorrect, not true. And if this is the approach, then it completely takes the answer to the wrong direction. So this is not how we're supposed to do it. This is how you're supposed to lay out your work, by putting in solid brackets like that. So this is two ways of getting things correctly in the exam. So 2 sine squared x plus squared x are like terms. So we have 2 and an invisible 1 over there. So it will be 3 squared. And therefore, concluding, we've just proved that the left-hand side is equals to the right-hand side. So the important takeaways here is to remember square brackets when you're dealing with the squared, and always remember your co-ratios, not to be confused by them. What's the next exercise? We also highlight important things to consider. So now we're still under the topic of identities. So given sine, cos, and that's always a good indicator that we're dealing with double angles. And this is a table that you always need to memorize this table. I extracted it from the Crack the Maths Code study guide that I wrote. If you're really interested, you can have a look at it. So the double angle, compound angle, I mean. So how do I see that? There's repetition of sine multiplied by a repetition. So if you look at your table here, you can see that, oh, something's interesting. They're starting with sine, but there's nothing that says sine. So the easiest thing you need to do, and rewrite this as to start with cos plus sine theta over 2. And we need to indicate that we're working with the left hand side. Now it looks a little bit more familiar because it has a plus sign in between and it's cos. So obviously we can see that we are working with cos plus sine, which means that we can reverse this and say this is simply the cos of angle we're working with. Here, angle we're working with could be sine 3 theta over 2, that can be of alpha, minus theta, which is theta. So this will give us cos of 3 theta minus 2 theta over 2. And how I simply did that is quickly, really with a small trick dealing with fractions. So if you wish, you can just use a calculator. Theta over 1, what I do is just multiply this by 2 and multiply that by 2, which will give me 3 theta minus 2 theta over 2. And the answer will be the cos of 3 minus 2 will be theta over 2, and therefore the left hand side is equals to the right hand side. So really the trick here was just rewriting this to something that you're more familiar with. And examiners really like these small tricks to throw you off your thinking patterns.